metal scrap or sponge iron is melted in an electric induction furnace. The molten metal at elevated temperature is poured into a ladle and directly casted to molds to form ingots and through a continuous casting machine to form billets. The mold filling using the runner and gate system is the traditional practice of converting molten metal into ingots. The system does not require any extra energy consumption, but for every heat cycle, it has associated energy loss of melting. Almost 500 to 600 kilograms of molten metal are lost in the runner and gates, resulting in increased specific energy consumption. The process of continuous casting machine has recently evolved into a cost-effective and environmentally friendly technology. In this, the ladle is placed above a tun dish and the metal is poured continuously through the tun dish into the caster. The primary and secondary cooling of the caster helps the metal to solidify during the process. In this process, metal can be casted into billets, slabs or blooms or the required shape. Output of CCM is billets typically of 100 by 100 millimeters and above. In case of composite units where the rolling mill also exists in the same premises, these hot billets coming out of the induction furnace can be directly charged into the rolling mill, thus eliminating the process of reheating furnace. The advantages of using a CCM with direct rolling are increased production and reduced specific energy consumption, scope of additional production line in future, reduced scale generation and support for direct rolling, improvement in quality of final product, continuous casting machine of lower capacity is available in market to cater to small capacity induction furnace, high-speed casting introduced for the purpose of direct rolling. Let's take the example of an induction furnace whose average heat time is of 2 hours, receiving 10 heats per day. The recommended CCM to replace the ingot molding is of a radius size of 4 by 7 meters with 2 stands. Thus, energy loss in a typical molding process is 220.85 kilowatt-hour per heat. The additional electric energy required for the CCM is approximately around 209 kilowatt-hour per heat. Thus, net electricity saving due to CCM operation is about 11.85 kilowatt-hour per heat. Hence, the annual electricity saving due to the installation of CCM is worth 2.5 lakh rupees. Also, production of billets leads to better profit margins compared to ingots, which in this case works out to be more than 1 crore rupees. Thus, the total saving through the installation of CCM is around 1 crore 3 lakh rupees. Thus, an investment of 2 crore 70 lakhs can be recovered within 3 years. In order to ensure optimum advantage of CCM, the mill should have direct rolling. Also, control of casting parameters should be ensured for optimum billet temperature at CCM cooling bed. The controls should be regularly monitored for optimum results. Regular maintenance of tun dish and CCM chamber is mandatory. It needs minimum 2 induction furnaces in running condition to give regular feed of molten metal to CCM. Installation of CCM needs space. The caster and transfer conveyor should be properly engineered and synchronized to extract 100% hot billet charging.